Hello. Today we're going to be proving congruency for triangles that have ASA and AAS. Last lesson you learned to prove if when two triangles are congruent, and you proved it by using SSS, side side side, and side angle side, SAS. So now the other two we're going to learn is SAS, angle side angle, and AAS, angle angle side. So the objective is, how do we use angle side angle, ASA, and AAS postulate to test for triangle congruence. Alright, so for angle side angle congruence, if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. And the abbreviation would be angle side angle postulate, or angle side angle, ASA. So you got to remember that you have an angle, you have two angles, and the side is in between them. Right, so we're going to do examples based on that. So for the first one, we have two angles that are congruent to each other, and then we have a side. So I'm going to use the highlighter to distinguish them. So we got angle A, and an angle X, and then we have the other angle, angle B, and angle Y, and then we have the two sides that are marked with a single tick mark, which are congruent to each other. So I'm going to have this AB and XY. Now I'm going to write the information that I need. So the first one would be the green. So it's that angle A is congruent to angle X, and the reason is given because of the marking. The side is going to be AB. AB is congruent to XY, and that's also given because they marked it with a little tick mark. And then we have the second angle, which is angle B, which is congruent to angle Y, and that's also given. So now we've proven the three parts congruent. Then we can do our triangle congruency statement, which is going to be triangle ABC is congruent to triangle XYZ. And the reason is angle side angle. Right, so let's do another one. They said that CB bisects angle ACD. So let me use blue. So if CB bisects this angle ACD, then that means that ACB is going to be congruent to DCB. So I put the two little marks, and I'm going to highlight that in blue. So these two are congruent to each other. And now I see this little mark. That's a 90-degree mark that tells you that this is two right triangles. So they're also congruent, because, let me put this in highlight purple, because if you have two 90-degree angles, it's going to create a line which is 180. So this is congruent to this. So CBA and CBD. And actually, you know, I'm going to start writing the information. So this was the second angle. So that angle is CBA, which is congruent to angle CBD, and that's given. And the angle that was in blue, because CB bisects them, makes them congruent. So I got angle AC, well, try that again, undo. Angle ACB is congruent to angle DCB, and this is the definition of angle bisector. So angle bisect, because it says that CB was the angle bisector. It bisects these two, that whole angle, to two congruent angles. This is the definition of angle bisector that makes these two congruent to each other. And now we're going to do the side, and that side would be CB. We got two triangles that share a common side, it's going to be a reflexive property. They're going to be congruent to each other. So angle, oops, not angle, side CB is going to be congruent to CB. And it's because of the reflexive property. And now we can prove that those two triangles, ACB is congruent to DCB because of angle side angle. So triangle ACB congruent to triangle DCB, and it's because of angle side angle. Right, and then let's do the last one for angle side angle. I'm going to look at what they have here. So it shows me that RS is parallel to QT, and then RQ is parallel to ST. That doesn't mean that they're congruent. This is what happens. You see these symbols, that tells you that they're parallel. It doesn't tell you that they're congruent. Because we could have one line that could be like 7 inches long, and then you have another one that's 3 inches, but they're both parallel, but doesn't mean that they're congruent. So now let's look for a side. Actually, I don't want text, I want just a pen. Oops, let's see. Take a while to load. Alright, so now I'm going to look at the side, the line that the two triangles share. So it's RT. So then this is going to be reflexive because it's sharing that, so it's reflexive, and I'm going to highlight that in green. Oops. Let's try that again. Undo and highlight green. Alright, so I'm going to write that because I already marked it up. So I'm going to have RT is congruent to RT, and it's because of the reflexive property. So reflexive property. Alright, now I need to find angles. So let's start with the blue. You remember about parallel lines and transversal? What they create? They create alternate interior angles. So then that means I'm going to put angle SRT, which is this angle, is going to be congruent to angle QTR. And this is the definition of alternate interior. So anytime you have a parallel line and a transversal cutting through it, alternate interior angles are going to be formed. So then we have this angle and then that angle. Okay, now I'm going to find the other angle. Again, these are parallel line, RQ and TS. So then they have this angle, and then this angle is going to be congruent. So we got angle QRT is congruent to angle STR. And it's because, again, the definition of alternate interior. That's all you would need to put. So anytime you have two lines that are parallel to each other and there's a transversal cutting through them, especially when you have to prove triangles, it's always going to be because of alternate interior, the definition of alternate interior. Now you can prove that the two triangles are congruent to each other. So triangle QRT is congruent to triangle STR. Oops. And it's because of angle side angle. You'll see the purple angle, the green side, and the blue angle. Okay, so that's all about angle side angle. Now the next one, angle side congruence, is basically if two angles and a non-included side of one triangle are congruent, to the corresponding two angles and a side of the second triangle, then the two triangles are congruent by angle, angle, side. So we're going to do just two examples based on that. I'm not going to do the middle one, I'll do the top and the bottom. So I'm going to start highlighting what they gave us or marked. So I see that K has the one little marking for the angle, and this one is congruent. And then I have another angle, this marker, the right 30 degree. 90 degree angle marker, they're congruent. And then I have the side, which is marked with one little mark, they're congruent. So now I can start writing my information. So I'm going to start with green. So I have angle K congruent to angle Y. It's given because they marked it on the triangle. Then for the angle, the second angle, which I put in blue. So I got angle J is congruent to angle X, and that's given. And then the third piece, which is the side. Oh, I have the dashed lines. I don't want that. That will be KL is congruent to YZ. And that's given. And now I can prove that the two triangles are congruent to each other because, so I have angle KJL is congruent to triangle YXZ, and it's because of angle, angle, side. Most of you might look at this and might think, oh, angle, side, angle. Basically, just follow the path. You start here, use the first angle, you see the second angle, and then you end up with the side. So angle, angle, side. Angle, angle, side. So like the other one where, go back to this, where you started first here with the first angle, you're going passing the side, and then you end up with the second angle. So angle, side, angle. So follow the path of your markings to tell you which one you use in order to prove the triangles are congruent. Alright, so let's do the bottom one. So I'm just going to mark anything that they gave me that I can find. So I already have the angle where we got angle Q and angle S. They're congruent to each other. So I'm going to write that. So I can start off with that. So I have angle Q is congruent to angle S because it's given. So I'm going to have to find the other angle. So for that one, let me use green for this. I need to make this an N. So I need to find the other angle. So remember, there's two parallel lines. We have this line, RQ, and TS. They're parallel. So that means this is the transversal. So remember, with parallel lines cut by a transversal, alternate interior angles. This only happens when you have a parallel line and a transversal. You can't do that for this one because they didn't state that it's parallel, but these two are parallel, and it forms a Z, that Z formation. So if I highlight that in yellow to show you that Z, anytime you see the Z, you know you're going to have alternate interior angles. So that is my second angle, which I'm going to show. So this angle QRT is congruent to angle STR, and it's because of definition of alternate interior. Okay, and the last one will be my side that I need to look for. These are two triangles put next to each other, so they're sharing the same common side. So that will be congruent to each other. And I'm going to write that RT is congruent to RT. because of the reflexive property. Now I can prove that those two triangles are congruent. So triangle QRT is congruent to triangle STR. This is congruent to STR because of angle. You follow in the path, angle, side. So angle, angle, side. Right. So we're going to use those two in order to prove that these two triangles that they told us are congruent. So they give us some of the statements, and we have to fill the statements and also the reason. All right, the first thing, I'm going to use green for that. So they said that angle N is congruent to angle L, and then they say that JK is congruent to MK. They already marked it for us, so that's fine. That works. So let's start off with what they gave us. So they said that angle N is congruent to angle L, and the reason is it's given. They told us. The next one, they said that JK is congruent to MK. I don't see this on the statement, so I'm going to write that in there. So anytime you start off your proofs, start off with what they gave you, and you know your reason will be given. So JK is congruent to MK, and that's given by them. So I'm going to highlight that in blue. All right, so now they gave us angle JKN. I'm going to use the pen for that. So angle JKN is congruent to MKL. And what's the reason for that? Look what's happening. You got two lines intersecting at a common point. The opposite angles are created. So it's definition. They're congruent because it's a definition of vertical angles. Okay, now I need to prove that those two triangles JKN and MKL are congruent. And the reason for that, let's look at it. I'm going to start with N, and I'm going to just follow the path. I got angle, I got another angle, and then I end up with a side. So it's angle, angle, side. They're congruent because of angle, angle, side. All right. So let's do another one. Okay, so again, they gave us some statements. The others we have to fill. And then we also have to give the reason for it. All right, so the first thing they say that DE is parallel to JK. So I'm going to put the little mark in that tells me that these two are parallel. So in my mind, I'm thinking if I have two parallel lines and there's a transversal cutting through them, alternate interior angles are going to be formed somewhere. But I have to find out which angle is going to form alternate interior angles. And then they say that DK bisects JE. So we got DK that bisects JE. So I'm going to take my pen. So this line is cutting this two into two congruent segments. So this is going to be congruent to this. All right. And let's see. And they want us to prove that EGD is congruent to JGK. Okay, so first statement. They said that the DE and JK are parallel to each other, and DK bisects JE. So that's given. They gave us that in the beginning. Now the next thing, since they said that DK bisects JE, I can say that with blue, I can say that EG, okay, this is, does it change that? Pen is wigging out on me. So EG is congruent to JG. And this is because it's a definition definition of line bisector. And then the next one says that DG is congruent to KJ. All right. So let me mark that. Actually, you know, that's supposed to be, that shouldn't be there. So I'm going to get that out because that is not, this one is a typo also. So I already have the two lines that are congruent to each other. Then the next thing I'm going to do is the angles, because they mentioned that the two lines are parallel to each other. These lines, DE and JK, are parallel to each other, so this would be the transversal line. So then here we have our alternate interior angles. And I'm going to show the Z anytime you see highlighter. I'm going to put that in yellow. So when you have a parallel line, and then you have the transversal, and then you have the other line, it forms a Z. Inside the Z, the bottom and top is going to form alternate interior angles. So with purple, I'm going to put angle D is congruent to angle K, because the definition of alternate interior angles. I'll just put alternate interior. Okay, so I have that angle. And now we need to find one more thing to prove that the two triangles are congruent. Alright, so I noticed that I got two lines intersecting each other at a common point G. So that means that vertical angles are going to happen. So this is going to be congruent to the other angle. So that means angle DGE is going to be congruent to angle KGJ, and it's the definition of vertical angles. Alright, so now I have an angle, and I have an angle, and I have a side. So I can prove that those two triangles, EGD, is congruent to JGK because of angle. So I'm going to start here, angle, angle, side. Angle, angle, side. Alright, so that's how you would use those postulates to prove that two triangles are congruent. So again, you see, that's the end. So going back, just to recap, you learned about angle, angle, side, AAS, and then you also learned about angle, side, angle. So you've actually completed the 4 different types of congruency in order to prove that triangles are congruent. So you had side, 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 you had side, angle, side, you had angle, side, angle, and you had angle, angle, side. So you learned all 4, and now you'll be able to prove if two triangles are congruent to each other. Alright, so this is the end, and see you around.